Okay, so what we'd like to start moving away from is relying on recursive sequences or recursive definitions to define a sequence that we're seeing for the first time, because as we've seen, recursive sequences can be kind of a pain if we're trying to find the 50th or the 1000th term. So what we'll do is we'll use these formulas that help us define a sequence explicitly to take any sequence and turn it into that explicit form. All right, so we'll start off here by just beginning with formulas that we can use if I want to turn either an arithmetic or a geometric sequence into an explicitly defined function. All right, so we'll begin with an arithmetic sequence, which obviously means that there is a common pattern that involves either adding or subtracting the same number every time. So if the pattern means you're adding the same number every time, whether that's a positive or negative number, then you can use this formula. And this formula just says that the function that you're going to build, a sub n, which again you could write in function notation as a of n, that would mean the exact same thing, is equal to a sub 1, meaning the first term in the sequence, plus d, and it's important here to note that d is not a function. D equals the common difference of all of your terms. Or in other words, whatever it is that you're adding and subtracting every time, times n minus 1, where again, n is the number of the term you're trying to find. So, for example, if we had a sequence that was a very simple one, like 1, then 3, then 5, and it's continuing, this is obviously arithmetic because we're just adding 2 every time. So if I wanted to build a definition for this that would be explicit, I could call it a sub n, and my first term, a sub 1, would be 1. My common difference in this case is 2 times n minus 1. And this formula would give me whatever term I want. So if I want to find term 7, I can just do 1 plus 2 times 7 minus 1, and that will tell me exactly what my 7th term is. All right, so it's pretty simple. If I get it to this explicit definition, then I can very easily turn that around and find any term that I want to in the future. All right, and then the second definition obviously is going to have to be for a geometric sequence. And a geometric sequence is different from an arithmetic because instead of having a common difference, we have what we call a common ratio. And so instead of D in our arithmetic sequence formula, we have an R in our geometric sequence formula, and R is representing that common ratio. So in our geometric sequence formula, we can say that the name of this sequence, defined explicitly, a sub n, or again, a of n if you want to write it like that, is equal to the first term in the sequence times whatever that common ratio is to the n minus 1 power. So, for example, if we want to build a really simple geometric sequence, maybe 4, and then 2, and then 1, and it continues, we've got a common ratio here, and what's happening every time is we're dividing by 2 or multiplying by 1/2. So in this case, our common ratio is 1/2. So my example of what an explicit definition for this sequence would be, I would call this a sub n, or a of n if you wanted to, and my first term is 4, my common ratio is 1/2, and my exponent is n minus 1. So now it's explicitly defined, and if I want to find the 18th term, I can just plug in 18 for n, and it'll give me that. All right, so from there, we're going to be able to pretty easily find any term we want to in the future for a lot of these sequences that will be given, and we'll be able to kind of steer away from the recursive definitions, which we've been using to this point. So let's take a look at the first part of this lesson here, the first example. And I'd encourage you to pause the video and try to do this on your own because I think you'd be able to do this first one by yourself. But what I'm going to do now is show you what you would need to do, which is just like the example that we went through with these explicit definitions. So the first 3 terms in an algebraic, and I'm almost certain that that's supposed to say arithmetic. Typo there. Sequence, a of n, are as follows. And they're telling you to name this function a of n. So use function notation here. And so you've got a sequence. They told you it's arithmetic, or that's what they were going for there. So we have to figure out what is the pattern here. If they told you that it's arithmetic from the very beginning, then you know that it's either an addition or subtraction pattern here. So the question really is, what are we adding every single time? And maybe we're adding a negative number and it's subtraction. But it looks like plus 6 is our common difference here. So from one term to the next, and the easiest way to find this is just to take term 2 and subtract term 1, and that will give you your common difference, right? 1 minus negative 5 is 6. So there you go. And that should also work for every other term, right? So if I do the third term minus the second term, I should also get 6. If I don't, then I don't have a common difference. But I do. So this checks out. All right, so now I can define A of n using my arithmetic sequence explicit definition formula, which is right here. It says that if I want to define this thing as A sub n or A of n, and I'm going to use A of n because that's what they told us to use, I need the first term, which is negative 5, plus the common difference, which is 6 times n minus 1. And that's it. Done. So if I did want to find term 82, all I'd have to do is plug in an 82 everywhere that I see n. And you don't need the previous term anymore because notice this doesn't say A of n minus 1, it just says n minus 1. If this said A of n minus 1, then that would be referring to the previous term, which we would have to know in order to find this term. And that would be a recursive sequence. But explicit definitions are way better because I don't need that previous term at all. All right, so they didn't ask us to do this, but we could do that if we needed to. So let's do the same thing here. We've been told that there is a geometric sequence in this second example, and they're telling us to call it B sub n. And the sequence is as follows. So if they told us it's geometric, that's important, then I know that there is a common ratio. So I'm going to be using my geometric sequence definition here, this formula that we're going to use. Just like above, when we were trying to prove what our common difference was, we can do the same thing to find the common ratio every time, right? I can take my second term, but instead of subtracting my first term, I can divide it by the first term. And that's going to tell me what my common ratio is. If we come back over to this example that we did over here, and I try to find the common ratio, then I do my second term divided by my first term. And what do I get? 1/2. I do my third term divided by my second term. What do I get? 1/2. That's why that is your common ratio. So here, just to check to see what that common ratio is, I'll do the same thing. Negative 14 divided by 28 in this case is negative 1/2. And just to check to make sure that it is a common ratio and that carries throughout the rest of the sequence, I'll check my third term divided by my second. And that's also negative 1/2. So this shows me that the common ratio is negative 1/2, right? Therefore, I know R. And so I can use my explicit definition formula here, the one that we were given, but I have to make sure that I call this B sub n. All right, so back to my formula. It says that I need the first term, which in this case is 28, and I'm going to multiply that by the common ratio, which is negative 1/2, and I'm going to raise that to the n minus 1 power. And so now if I want to find term 75, I just plug in 75 in for n. Okay, I think at this point, I'm going to leave you to do the last two here before we get to class. So before you come to class tomorrow, finish these two examples. And this one is just referring to the sequence that you just used. And this one here is a brand new problem. And you should be able to do all this using your explicit definitions. All right, so try to finish those two before class, and I'll see you guys tomorrow.